Generator is a special function which is actually responsible for generating a sequence of values. So we can write a generator function just like we define an ordinary function. But because a lot of sequence of values are being generated by this function, we need to use a keyword that is yield in order to return the values. Now the syntax is we generally use the same def followed by some function name, but inside the body we are supposed to write the yield keyword followed by a value. Now what are the key features of this generator function is we definitely supposed to use the yield statement because the yield statement is going to produce the values. Second one is your state preservation. I mean, whenever generate function executes, it is going to keep a lot of values. I'm going to generate a lot of values, but we can get the value that is generated out of its generator by using something called as your next function. Lazy evaluation, that is nothing but generator function only calculate the values when the next is called. So unless until we call this next function, the next value which is supposed to be generated by the generator is not generated. So generator function, though it is responsible to deliver so many sequence of values, but it is going to get me the value only when we call the next function. So what are the benefits of this? Memory efficiency, because generator functions are going to use very less memory. The reason is they do not store all the values at once. For example, let's say a generator function is producing some 5 values. So all the 5 values will not be stored in the memory because each and every time whenever I call the next, then only the function is going to supply one value to me. So if I have 5 values present in a generator function, then I need to use next function 5 times so that I can get all the 5 values one after another. So as it do not store any set of values in the memory, so it uses very less memory. And this function can also be used to generate some complex sequences. Let's understand the usage of this generator function. So here we are trying to define now one function, let's say finite sequence, taking one parameter here. And there is a for loop which is applied on the range function on whatever value we supply to this function. And every time it is yielding one element or one value. Now in this particular line, we are making a call to this particular function because generator is also a function. But when I'm calling this function, I'm passing the argument as 3. So that is the end value. So as a result of this for loop is going to work 3 times for I value 0, for I value 1 and I value 2. So this yield I is actually going to return the corresponding values each time I call the next function on it. So now gen has the set of values which are to be returned out of this particular generator. Now in order to get the first value, I need to apply the next function on this gen. So next of gen is going to invoke this yield, and because the first time we have called next, the first value is returned, that is nothing but 0. And for the second time when I'm calling again next of gen, so the next value that is to be yielded by this function or generator is your 1. And likely for the last time when I'm calling next of gen, I'm going to get the last value that is 3 here. Suppose we have taken one more example here, which is an infinite sequence. So this will produce many numbers. We do not know how long or how many numbers, but what we are looking for is we are trying to get the values as long as possible. I mean, in the previous example, a maximum I could get only 3 values because we have fixed this. But here I am not fixing anything. Rather, we are trying to use the next function as many times, and every time you use the next function, it is going to produce one new value out of the generator. So here we have taken or defined one generator and took some num equal to 0. And here I'm using a while true loop, and within that we are using this yield. And what this yield is? Yield is returning this value of num, current value of num. And after every time the value is returned, it is updating the value of num by 1. Which means this entire generator function is going to produce the value starting from 0, 1, 2 and so on till n. And we do not know what is the value of n here. Okay, so here we are calling this infinite sequence, this generator function, which is represented by your gen. So now when we call the next of gen, the first value that is yielded by this generator is your 0. When I'm calling for the second time, I'm getting 1, and for the third time we are getting 2. So if we continue here as many times, suppose next time we'll call next of gen, I'll be getting 3, and there is no limit. It keep on producing a sequence of values. So let's see one more example where we are trying to use a generator function to print the Fibonacci series. Now, here we have defined this Fibonacci function, which is nothing but going to act as a generator because we have a yield here. So here we have called the Fibonacci, and the respective values are going to be getting stored into this gen. So we have taken a for loop here. So range of 5 means this is going to execute. I mean, this print statement will execute 5 times. Okay. So for the first time when this line gets executed, so what we are trying to get is, we are trying to get what is the value that is generated out of this generator for the first time. So as a result, what happens? The control goes here. We have taken here A0, B1, and while true loop gets executed, and what does it yield? Whatever the yield followed by value is there, that is what we are going to get whenever I call the next gen. So what is the present value of A? That is 0. So hence we will get the first value that is printed as 0. Now the second time when this line executes, again we are calling the gen function. Okay. So after this first value is been supplied or yield, then there is an updation done to this A and B. So A takes the value of B and B takes the value of A plus B. That is, A becomes your B. B means nothing but your 1. So A is 1 and B is going to be A plus 1. That is 0 plus 1. That is 1. So for the second time when you are calling this gen function, I mean next function on this gen, so this is going to yield the present value of A. What is the present value of A is? That is 1. So hence we get this as 1. Again this updation has been done. A takes the value of B, that is nothing but 1 here. Whereas B takes the value of A plus B, 1 plus 1, that is nothing but your 2. So now when I call the next function for the third time, so it is going to yield A value. What is the A value here? 1. So we are getting 1 once again. Again this is getting executed. A takes the value of B. What is the value of B? 2. So A becomes 2 here and B becomes 1 plus 2. That is nothing but your 3. So now for the fourth time when I'm calling next of gen, so we are going to get the present value of A, that is nothing but your 2. So we are getting 2 here. And then this line gets updated. So A takes the value of B, that is 3, and this B takes A plus B, that is nothing but your 5. So for the last time when we call the next function on this gen, we are going to yield A value, which is nothing but presently 3. So like this, we can get a series of numbers present in the Fibonacci with the help of a generator function.